All right, we are live. Welcome to this edition of the vCluster live stream where we're going to feature version 0.29, a new release of vCluster product. I'm your host, Scott McAllister, a developer advocate, and I come to you from Seattle, Washington. So we'd love to have you in the chat. Let us know where you're from. We see Simone over on YouTube has already mentioned he's from San Francisco. So let us know where you're dialing in from. We love seeing where folks are from all over the world. I'm joined today by our CEO and co-founder, Lucas, as well as Pavel. I'll have you two introduce yourselves.
Pavel, why don't you start?
Yeah, hello. I'm joining from Warsaw in Poland. I'm a staff software engineer at Loft, and we'll be happy to demo the stuff that we've been working on for quite some time.
Awesome. I can't wait to see that demo. And yeah, hey, I'm Lucas, the CEO and one of the co-founders here at vCluster Labs. Got the whole vCluster thing started with Fabian in 2021, the open source project. And yeah, we're excited to see where we're taking this and how we're expanding the scope of vCluster. Obviously, this has been a very, very busy summer for us. Bunch of new releases. Yeah, Scott, do you want me to dive right in?
Yeah, let's do it. I'll pull your screen up. Let's go.
Cool. Awesome. We had a series of releases this summer. We called it the Future of Kubernetes Tenancy. You know, we're really seeing ourselves as building the infrastructure tenancy company here. We started with multi-tenancy for Kubernetes, predominantly focused on the most lightweight, soft multi-tenant Kubernetes clusters that are great, ephemeral clusters, great for development, great for pre-production. But over the past couple of years, our user community, our customers have asked us, can't we put this in production? Can't we get harder isolation? Can't we get more, security boundaries up? So this year has been all about, addressing these topics. And in August, we started this launch series with an announcement called Private Nodes. Private Nodes effectively allows you to take a node and kubeadm join it into a Kubernetes control plane, into a vCluster control plane. Which is really exciting because that node is now not part of the host cluster. Typically in a vCluster, you have a host cluster, so an existing EKS, GKE, OpenShift, whatever Kubernetes cluster you already have, and then you spin up vClusters on top of it. And these vClusters use the nodes from the underlying cluster. But with private nodes, it's different. You take a completely separate node, right? The control plane still runs on a control plane cluster. There's still a host cluster that runs, 20 different control planes. And these vClusters, they're regular Kubernetes control planes, effectively. They're upstream Kubernetes. They're bundled a little bit differently. We do it very, very lightweight. It's a single container. It runs in a namespace. Obviously, 1HA, it's 3 containers. But, if you want to have a node specific just for that one vCluster, so far you could do things like node selectors, etc. But the CNI, the CSI and a bunch of other things are still shared because the node is part of that underlying host cluster. Private nodes change that. You can effectively kubeadm join a node directly inside the vCluster control plane, and it has a completely separate CNI, CSI, so network storage. Everything is completely separate for this vCluster and for these private nodes that you're adding to it. Obviously, increasing the isolation level massively. And this is kind of the way how a lot of cloud providers run their Kubernetes offerings. Whether you look at the neo clouds or more traditional Kubernetes offerings, like maybe DigitalOcean's, right? Under the hood, a lot of folks run these Kubernetes control planes and essential components as containers, and then they kubeadm join, VMs and bare metal machines directly into the control plane. So private nodes really get you that same level of production greatness where you could literally run a cluster for Pepsi and a cluster for Coke on the same host cluster, but because the nodes, the networking, everything is completely isolated in these control planes with regards to these nodes that you're joining into, there's really complete separation and production here. Then we had our second announcement just a month later in this launch series. It is called Auto Nodes because we're obviously aware that manually kubeadm joining nodes into a cluster, that's like Kelsey Hightower's Kubernetes the hard way probably, or like very close to it, to be honest. And we don't want to go back to these times, right? We want to automate. We want things like streamlined. That's why we announced Auto Nodes. Auto Nodes effectively allows you to enable Carpenter directly inside vCluster. It's an open source project that AWS got started a couple of years ago. They baked it into EKS. They call it EKS Auto Mode. We're kind of like getting close to that naming territory here. Obviously, it's a little bit of play on words on EKS Auto Mode. We call it vCluster Auto Nodes. And effectively, it's our take on how to implement Carpenter and bake it directly into vCluster. It's the upstream Carpenter. We made some slight modifications to make it slightly better for vCluster, but it is effectively direct Carpenter. And that means you can now join nodes directly, automatically into these vClusters. You don't have to do the manual, SSH into a node, running kubeadm, installing, containerd, etc. on the node. Like all of that is completely automated. It works directly with Terraform and OpenTofu, etc. So it is very, very flexible. It works for hyperscalers, all the neo clouds that have Terraform providers, any regional cloud provider you may be using. A lot of them have Terraform providers. Even things like Metal as a Service or OpenStack in your private cloud. There's probably Terraform providers for pretty much anything you could think of. And if there isn't, well, you could write a Terraform provider for it, right? But we also made direct integration into KubeVirt, which is really exciting to spin up a bare metal cluster of nodes, have KubeVirt on top, and then gets right-sized VMs, almost like EC2 right-sized instances on top of these bare metal nodes. That is also possible with our Carpenter implementation and auto nodes. And last but not least, we also build an integration for NVIDIA BCM to directly hook into these AI supercomputers that spawn up GPU nodes on bare metal. Obviously, really, really excited about all of this deep work on with vCluster on GPUs. And we are in the process of also adding AutoNode support for cluster API node providers, infrastructure providers in cluster API, which is really exciting because vCluster already has an open source CAPI provider for the control plane. So wouldn't it be nice if AutoNodes could directly use CAPI as well in order to provision and join nodes? That is on the roadmap. It's not out there yet, but we do have a working prototype already. So stay tuned for that update. Hopefully, Scott, I'm not spoiling too much here, right?
Oh, it's exciting though. It's exciting to see where we're going.
Yeah, lots of changes this year, right?
Yeah.
Probably we're going to see a lot of this in the demo as well. You're demoing AutoNodes too?
Yeah, so I don't want to spoiler the last part that you haven't talked about yet, but we're gonna start with this last part, and then we'll also show how this all ties together with private nodes and the auto nodes as well.
Nice.
Awesome. That sounds fantastic. So let me unveil the last part here. Some of you have obviously seen this. We made an announcement earlier in October 1st. We call it vCluster Standalone. And Standalone really adds the capability to run your vCluster as a binary, so as a process directly on a node, rather than running it as a container on top of a cluster. And that is really important because generally, when you think of a greenfield environment, right? Think of one of these AI supercomputers with GPUs. You just got the hardware. You want to get started with vCluster and this dynamic auto nodes for your GPUs on top of that. Well, you kind of have to ask yourself, vCluster has to run as a container in some other Kubernetes cluster. So how do I bootstrap that cluster number one, right? That cluster one problem is definitely real in a lot of these greenfield environments in particular. And if you have vCluster standalone, it is just like, OpenShift or RK2 or K3s, you can bootstrap the cluster, not based on based as a pod. You can run it as a binary and directly run it on a bunch of VMs or bare metal hosts. And that obviously gives you capabilities to spin up that first cluster and launch a bunch of vClusters on top. Or maybe you just use that cluster directly to interact with it, right? The same way as you would use any kind of, K3s cluster, for example. So just to quickly show the overview here, very, very high level. The traditional vCluster, if you have a vCluster, A and B here, they would run as pods inside namespaces of what we call the host cluster, right? So this is really our control plane cluster. So I'm spinning up a cluster that is supposed to run control planes predominantly. It can obviously also have, worker nodes that these vClusters could use if you want that level of softer tenancy and sharing. But if you're going the private nodes approach, you would take a node and directly join it into this vCluster. You would take 2 other nodes, join them into this vCluster, and now you have 2 vClusters running as pods, and you have the worker nodes directly, kubeadm joined into them to form completely separate, isolated clusters, separate CNI, separate CSI, etc. What does Standalone do? Well, instead of using this host cluster, because it doesn't exist yet, you take a bunch of nodes. Maybe you take like 3 nodes. These could be VMs or bare metal machines, right? And you start a vCluster standalone process as a binary on top of this node. So you have control plane nodes, just traditional Kubernetes, right? You start with one control plane node, then you can join additional ones to it to run the vCluster binary on top of that, to add HA to your control plane, and then you can kubeadm join your worker nodes. And again, we baked auto nodes in here as well in this approach. So for either of these options, you can have the worker nodes automatically provisioned with things like Terraform, OpenTofu, NVIDIA BCM, in the future CAPI, KubeVirt, very, very flexible in how to do this. And I think with that, we'll get right into the tech, right? And Pavel is going to show us how this works.
Awesome. Let's add you to the stage. Here we go.
Yeah, so we'll start with just one node cluster. So we'll start with just starting the vCluster standalone cluster. So, sorry, vCluster standalone, really. So to do that, we're going to go to the vCluster documentation. And in the deploy section, there are now 2 options. You can deploy the control plane as a container, which is this traditional shared host vCluster, but you can also right now deploy it as a binary. And we're gonna do just that. So deployment process is quite simple. You declare which version you want to use, and then you just download the install script, which is the release asset of every vCluster release, and then you have to run it. You can declare the vCluster name and other parameters. And the most important thing is that you need to have a VM or bare metal server where you would run it, right? So I've prepared 4 VMs for that. So we're gonna start.
This is on your home lab supercomputer with tons of fancy H100 GPUs, right?
You can say that. It's just my laptop, but some people call it that way. Yeah, okay.
By the way, I love that you started with the docs here. Shout out to the docs team. That's obviously a difficult question, right? How do you show that in the docs and explain this as a container, this as a binary? I think they found a really nice solution on how to explain that. So
I think these diagrams are great on the docs homepage, where you can. It basically covers like what you've been talking about, like this whole 3 tenancy models. Actually, more than 3, right?
Yeah.
They keep on expanding.
Yeah.
Yeah, I stopped at 3. Yeah. Time flies. Time flies. Okay, so the most important thing is you need to configure your vCluster YAML, and you need to specify that you will run your vCluster standalone. So to do that, you just enable the standalone flag. Then you need to make a decision whether you just want to use the VM as a host for the control plane, but there is also an option to install additional components on that VM and have it join your cluster as an actual node, as an actual Kubernetes node. And we're gonna do that. So yeah, maybe without further ado, let me just copy the configuration I've prepared.
While he copies that, if you need us to increase the size of the font or anything on the screen, just let us know in the comments.
Scott, have you spun up a vCluster standalone yet?
I have not yet played with it. No.
Got it. It's about
Yeah.
time.
No, I know it looks amazing, and I love the idea, the fact that it can just be vCluster from beginning to end, rather than having to like get another distribution and then add vCluster to it.
Yeah, it's vCluster turtles all the way down, I guess, something like
Yeah,
that, right?
yeah. Yeah, that's true. So going back to the configuration, there are a couple additional options that I will configure here. So we'll start with just one node, but later on I will attach more nodes to it, and I also will make sure the control plane is highly available, and we're gonna do that by just running 3 replicas of vCluster standalone and the control plane. So to enable that, I need to pick the right packing store, and in my case, it will be embedded etcd. And the idea is that once we have the first control plane running, then we can add more control plane replicas, and all 3 of them will create etcd cluster as well. So that way the storage is shared for the cluster, right? I will also use the private nodes, which is right now the only option for standalone, but that's for later. Later on, we also talk about the auto upgrades, what it means, and yeah, I'm gonna pin the Kubernetes version that we're gonna use to 1.33 because later on we want to demo the auto upgrade as well.
Oh yeah, 34 is the new one, right? We're one version behind, I guess.
Yeah, that's the only way to demo upgrades. You have to start.
Yeah, hopefully not showing downgrading, right? Upgrading is better to show instead of a rollback.
Go the right direction.
Oh, okay. Yeah, there is one more thing I forgot to mention. We're gonna connect this standalone cluster. From the start, we're gonna connect it to the vCluster platform. So to do that, I had to create the access key. I also have a platform deployed already, and I'm just gonna copy the platform host and this access key and pass it to the install script. So when the vCluster standalone comes up, it will register itself in the platform, and it's great because this way we can, at least for a while, switch from the terminal demo to the browser demo or like UI demo, which is, I guess, way more attractive visually, right?
Right.
Yeah, the UX team will thank us for showcasing the UI a little bit as well, right? Sometimes people are like so focused on like CAPI and like YAML, right? That we don't actually always pull up the UI in demos, and yeah, I feel like sometimes it's a missed opportunity because the UI is actually really cool. It hot reloads. There's lots of options you can do. You can stream the logs. You can exec into a container, right? There's a bunch of things you can do with it. And it just gives you a good overview of all of your vClusters and all of this. And so you just passed on like the platform host and the platform access key as 2 additional arguments.
Yeah, exactly. Right? And I also passed the name that will show up later in the UI. So we expect my vCluster to be named standalone demo. And we can see that it is initializing. It seems that the control plane is already up. We see no nodes yet because I think we are in the middle of joining nodes. So the control plane is up. It should show up in the UI just in a second, I believe. And later on, what's going to happen, the control plane itself will deploy the node components and that stuff like core DNS, CNI, also connectivity. And once all these are running, our node should also show up as ready, right? Because currently it shows up as not ready. And as I promised, we can also switch to the UI right now and see all that in the UI. So we have one node currently. It's not ready, right? Because this node components are just creating, but I think eventually it will, it shows up as ready. Which is great. We now have fully functional cluster with just one node. And I guess for some folks that will be sufficient, right? But we want to also showcase how you can start small with just the control plane and one node and then make it highly available and later on attach the worker nodes as well. So yeah, the question right now is how to make it highly available. So there are some configuration options I had to enable from the beginning. I think I've already talked about the etcd, embedded etcd being the backend store, right? Correct me if I'm wrong, Scott. But I think I did.
Yeah.
Yeah, great. So right now we have the control plane running, and we need to generate the token for another control plane replica to join. And doing that is actually quite easy. It's just one command that we'll need to run on that control plane machine, right? So in the control plane, the vCluster CLI is already baked in. I mean, it's installed automatically. So you just need to execute this command, and it shows you the control plane endpoint with a token. And it's actually, if you query that, it will return the join script. So the idea is that now you can copy this command, and we'll move to the second node, which we want to join as a control plane node. And we can just execute that. And basically that's it. That should do for joining another node.
And what's that second node and the third node? Did you actually spin up like an EC2 for this, or a local VM, or how did you create these two nodes?
So these are local VMs. But later on, I want to show the auto nodes for the EC2. But right now we are still in the we still haven't moved out of my laptop really.
I got it. So you have 3 VMs on your local laptop right now that you spun up, and that's the 3 terminals at the top here, right?
Yeah, and actually there is like 4 VM, which I will also showcase how you can join the worker node without the control plane.
Nice.
And maybe we can go to that directly.
And actually, we have a question. Speaking of VMs, are we able to get a VM with vCluster Standalone already installed, so they don't have to do the curl up front?
Currently, I don't think so, because I guess that would have to be some kind of VM image, right? With,
yep.
So I don't think we build that as a part of the release process, but the actual installation is one curl, and then you execute that. So I think we can totally do that at some point needed.
Yeah, at the risk of spoiling too much again here. But we have an internal thing already, prototype working, where you can actually use the auto nodes feature in vCluster platform to provision nodes for control planes. So you basically on vCluster platform, when you say, hey, you have my AWS credentials, here is a Terraform template for provisioning EC2 instances, or some other, Terraform for your OpenStack, or you have KubeVirt connected, right? And you effectively say, please spin me up, a standalone cluster HA with 3 control plane nodes, and it's going to use auto nodes, and it does a Terraform run to effectively provision these standalone control plane nodes, then join them into the cluster directly, just like manual process you're running right now. And then additionally, you can have auto nodes for the worker nodes as well. So it's across the board: control plane nodes, worker nodes, everything provisioned via auto nodes. But again, I'm spoiling again. This is not live yet. You can't test this today.
I think that's gonna be the next webinar, right?
Yeah, it's the next one.
Yeah. So definitely sign up for that one. I think this is super, super exciting. So
That's exciting.
Yeah, Simona, thank you for asking that question. That is a great leeway into the next live stream here.
Okay, and I think we've annoyed the demo gods because for some reason I cannot get it to work.
Oh yeah, we're probably talking too much. Sorry.
Yeah.
We should let you focus on this demo over here. What's really cool, by the way, is I don't know if people have noticed this, but the curl command, when you run, vCluster token create, right? So you're running this CLI command. What it spits out, what publish just copying over here. That URL, that HTTPS, 10.244.0.25, that is actually the IP address of that first control plane that we spun up, right? So we have that first node with a control plane running, and that you join a second node, and it's retrieving the join script from that first control plane node, which is really cool because that means you don't need any connection, any outside connection, right? Obviously, we could have placed some static script and then, made some replace action, right, with some commands. But instead, we just baked it into control plane as an endpoint, right? An authorized endpoint. That's why there's obviously a token here provided. And since this is Pavel's local network and not exposed to the public, we're not too afraid showing this in this demo. Hopefully, you got a firewall and a router and everything set up in your local home network, so people can actually join stuff into your control plane. But yeah, this is, I think, one of the most exciting parts. When I saw that, I was like, that's such a smooth solution to this like kube-adm join problem. Because people think like kube-adm join, that's like really straightforward. But there's actually a lot of stuff involved, right? It's like getting containerd up and running and a bunch of other things. And also, how do I get even that command and like things on that machine? So this is just a curl, run it, and you're good to go.
Yeah, that's right. I think from the day one, we tried to have like air-gapped environments in mind. So we design it in a way that you only need network connection to this first already existing vCluster standalone control plane, right?
Oh yeah, makes sense for air-gapped, for like VPNs, right, where just the connectivity to the outside world is much tougher. This is obviously great because obviously these control planes need to talk to each other anyway. Otherwise they can't do any kind of like leader election, right? So yeah, that definitely needs to be some kind of etcd quorums and stuff like that. But yeah, that's a really great option.
Yeah, so what I tried, I restarted my VM with hope that it will fix the issue we are seeing right now. If it does not work, I guess we will move on to the auto nodes part.
Yeah, local VMs are always tricky for demos. I've done a bunch of demos with that as well. Local VM setups are always a little bit messy, networking wise, and all of that stuff. There's just a lot of things that can go off whack here. Maybe we'll actually need to give you a rec for you should expense a little rec for at home to make it easier.
Everyone should have a good home cluster, right? Yeah,
it's true. True. At least some Raspberry Pis.
I was going to say, give us a stack of Raspberry Pis that we can put in a little rack on our desk.
Can you put like Proxmox on like Raspberry Pis or something like that? Some lightweight or KubeVirt? Maybe you could do like a KubeVirt cluster actually, right? That should be possible.
Oh.
Yeah.
All right.
Yeah, I think we can also try like one last time. I will just increase the timeout on this one. Just hold on a second. Yeah.
The beauty of all this is that we're engineers. All of you watching, you're engineers too. So you totally get this. You totally get the fact that you build a thing, you're showing a thing, and then you go, oh, right. Now all these other things aren't coming together. So thanks for being patient, y'all. And this is fun live.
Yeah, that's how you know it's a live demo and not scripted, you know.
Yeah, it's especially fun that, you know, when you try this demo multiple times before the demo.
Yep.
Only when this camera rolls, sometimes some things just break out of the blue. Yeah. Okay, let's try one more time, and then we're gonna give up. I guess in the meantime, I can talk a bit what we're gonna do next. So as I said, the UI is great also for auditing your resources in the cluster, but there are also some features that are accessible from the UI, and like it's way easier to configure them through the UI. And one of such features is auto nodes, because later on what we are planning to demo, and hopefully we'll be able to demo that. So in the UI, you can create your node provider very easily, because we also prepared the quick starts for the node providers. And you can, for example, you can create the node provider for AWS EC2, which means that you're basically telling the carpenter, which is baked in the vCluster, that here is my node provider, right? So I already have one created for EC2 instances. It's automatically picked some of the instance types. I can modify them here. And what I can do later on in my vCluster standalone, I can configure node pools, right? So I can configure dynamic or static node pool. In my case, I think we're gonna configure the dynamic one to show the scaling up. And doing that is actually super easy through the UI, because you just pick the name for your node pool, you pick the node provider, and you can also set some limits, right? So you can set like maximum 3 nodes. And that's it. And that will output your vCluster YAML configuration, which is needed, right? And what we can do, we can just copy it and use it directly in our standalone. And I think we're gonna just move to that, because there are some timeouts on my local VM, so that's probably not gonna work. Sorry about that. Yeah, so we configured our node pool, right? And we are going to showcase auto nodes right now. So I've just updated my vCluster configuration to include the dynamic node pool, and I wanted these nodes to use EC2. So what we need to do right now, we need to update the configuration on actually only on this node, and we can
makes the demo a little easier if it's not an HA cluster, right?
There you go.
Yeah, makes it a little easier. I was actually a bit worried about demoing that on HA cluster, because then you need to, not worried, but you need to update the configuration manually. This is something that will be also addressed in the next release, because then you would need to just update it in the UI, and it will be automatically synced across your control plane nodes.
Yeah, there's lots of automations coming. I think vCluster standalone right now is the first way get standalone even running. It's kind of like private nodes, right? We shipped that first, and then 4 weeks later or so, we shipped auto nodes, which is the full-blown like automation suite, lots of UI things in the platform. So we're doing something similar here for vCluster. And just to recap, so there's a file, etc vCluster YAML on the control plane node that you just updated, right? And then you restarted the vCluster service, right? Like the vCluster daemon that runs on that node in order to reload that configuration, right? And what you added was you added auto nodes, and you said you want dynamically EC2 nodes provisioned into this cluster.
Yeah, exactly. What's there is like one other cool part of it, and it's also a bit of a spoiler. But we'll be attaching the EC2 node to my local cluster, so you may immediately think, how is that possible?
Oh, yeah, I know where you're going with this.
EC2 instance will be able to connect to the control plane, which runs on my laptop. And it's thanks to this VPN feature that we will probably talk more about on the next webinar. But effectively, what happens is that it creates the VPN. So the EC2 instance will join this VPN, and that way it will be able to connect through the tunnel to the control plane, which I think is pretty cool as well. But
that's a spoiler for next Tuesday. That's our release next Tuesday
okay.
for GTC Washington. If anybody is curious when you can get your hands on this like automatic VPN, there's a bunch of features that are shipping next week, and this is definitely a big one, because obviously if you have auto nodes and you want to have some auto nodes provisioned with KubeVirt in your private cloud, and then others with EC2 in the public cloud, how does pod-to-pod communication work? How does a worker node in EC2 connect to your private cloud control plane, right? Like all of that needs to happen securely over the wire, and that's really what this vCluster VPN is for. So yeah, anybody who is missing this stream that we're doing right now is really missing out on all of the spoilers. So you should have definitely joined.
We're gonna retitle this to just spoiler alert. That's what's gonna be.
Yeah, I think we have one more issue, unfortunately, but I will try to work around it. So what happens is when you create the node provider and then you configure your virtual cluster instance to use auto nodes, right, and to use like dynamic or static node pools. The first thing it will try to create a node environment to ensure that this provider will be actually able to create the nodes for you, right? So this way you don't have this issue that you need nodes. Carpenter will try to provision nodes, but it will fail, right? So it does that immediately to verify that it's gonna work. And bad news in our case, it seems that it's not gonna work because we reached the quota on VPCs in that region.
So I guess everyone's been practicing this demo quite a bit today.
So I think what I can try to do off camera, I can create the new node provider in another region, and we can just try that. But I will need to stop sharing because
let's do that.
You don't want to show us your creds? Come on.
Yeah, like you can either
show us some ClickOps in AWS.
right. I'll take your screen off the stage there while you do your thing. So it sounds like a lot
funny, though. Maximum VPCs. That's such a gotcha.
Yeah, I haven't seen
that. That's how
you
can tell. We have sandbox environments, right? And the IT operations side of the company is putting guardrails in place, because probably I'm not sure, is there a load balancer for each one of these, or does the VPN cost itself? Probably, right? There's probably a price tag attached for everything in AWS.
Yeah. I know I've hit that VPC limit many times when trying to set up demos and things. So it's it's definitely it's there, right? It's so we're not just throwing money at Amazon for no reason.
Yeah, I think the funniest thing is that the more you try to ensure that your demo works, the worse it can get on the VPC limit, right? Because it will create. So yeah. I can assure you that it was working when I was trying it just before the demo, but it makes sense that.
Yep.
I may reach.
Yeah, you were quick to spot that error message though. That was like a long AWS output. I was like,
right?
gosh, I don't even know where to look.
I have to say,
it's almost
the
like
UI support for it is great. So
that's true.
It's
yeah.
super easy
Marked
to
really nicely
spot
read.
this. Yeah,
that's true. Yeah.
Because when you do have issues, that is the most important thing, is that you can figure out what's going on. That's the most frustrating thing, is when you have an issue with any type of system and you can't see a good error message and you can't see the output. You're like, okay, what I need to at least be able to debug this thing. So having the UI being so visually organized so well, it makes it really, really nice for debugging.
Even if your GitOps infrastructure is code shop
Yeah.
and you're like, nobody does ClickUps here, we don't want the UI, right? I would still say, maybe take the create and apply permit, like it's just regular RBAC, right? So anything in the vCluster platform, and by extension the UI of the vCluster platform, is adhering to regular Kubernetes RBAC. So just give people read permissions, right? Like that, let them explore these errors, let them debug, right? Let them stream the logs, right? Like there's a bunch of things you could still allow, even though you may be, strictly adhering to everything's got to be a pull request, everything's got to be approved, right? And reviewed before it can go live. I mean, I get it. Maybe for like ephemeral, vClusters and more like pre-production ones, I've seen a bunch of teams try to go this like GitOps route and then ultimately regret it, because the whole reason you set up, like self-service clusters and all that stuff is like so people can iterate fast, right? And then now, like creating a pull request and then waiting like a day or two until somebody feels like, I mean, it's a little better than filing a ServiceNow ticket. I get that, right?
Right.
It is not as nice as if you could just like go into the UI or like just a CLI, vCluster create, boom, like there's a cluster spinning up. So I always, when we start talking to organizations and they want to put vCluster in a bunch of different places and they have many use cases, I always tell them is like, does this environment really need to be reproducible, traceable, because like if it's an ephemeral kind of throwaway test cluster, I mean, do you really care, right? Like maybe you templatize them, which is possible in vCluster platform. You can create templates for them. And that way you kind of get that, experience of like standardization and rolling back and fleet management, right? But without actually hampering, kind of people's ability to move quickly and just kind of spin up a bunch to get going.
Yeah. All right, Pavel, I'm seeing... Are we seeing good things on your screen? Not bad things?
No. Just hold on a second.
Okay. Don't want to put bad things.
It's funny because we can see the screen here, right?
Exactly. Yeah, so like
we're like Scott and I are stalking you right now. Like we're invested in seeing what you're doing. So when you switch just like briefly over to the platform, we're like, oh, we're good to go.
It works. Yeah.
The audience is like, why are they so focused? Like looking at the camera trying to read something. It's just...
Yeah, I can tell you what I try to do. So I try to use different region, but it seems that the credentials I have have some kind of restriction on the region. So what I'm going to do next, I'm gonna use the different AWS account, and I think that has potential to work. Because maybe on this one we're not gonna hit the quota.
all I'm hearing is Pavel just asking me, "Can you make me AWS admin?"
Yep. I think he's also asking, "Can I expense this? Because this is going into my account now."
Lucas, can you just increase the quota?
There you go.
Yeah, actually, I don't even know where to go for that, to be honest. AWS console, I'm always lost.
Fair. So
Okay.
I've also been told, as a CEO of the company, when you're a startup, you're very small in the beginning, right? So co-founder and you're just kind of like, the early days. I mean, everybody's admin, right? And like, you just kind of wing it in terms of because
yeah,
you're trying to clean up after yourself, but you never fully.
you have
We
no
just found a
need, right?
database
It's
the
only
other
just you
day
and
from
him.
like, we found a database the other day from like 3 or 4 years ago when we just got the company started, and it was so funny because Flavia was like, "Are you using this?" And I was like, "No, isn't that yours?" I was like, "No, I'm not." Like,
Let's
nobody's
spin
touched
that
this thing.
down, man.
We're like, "What's in there?" And
Yeah.
there wasn't much in there. It was just kind of like a playground thing where we were kind of demoing and trying out something. Like obviously we added like different backing stores to vCluster. Probably comes from like, those early period of times. But yeah, you definitely need some kind of guardrails and reproducibility in AWS, and Terraform and stuff like that helps a lot already. I think that's what we're doing predominantly today as well. So I've been told by our operations team not to, I still have the AWS credentials. I could technically sign in to like the root level account and
Sure.
stuff like that. But I've been very clearly told that this account is audited. Every sign in and every action is logged. And that our SOC 2 and whatever policies don't really like me doing that. So
No.
yeah, I restrained from doing that.
Even you aren't above the law. So
Yeah, I wish, Pablo, I could just like press 2 buttons now and make you admin for unblocking your demo here, but
Yeah,
A, I don't know
hopefully.
where to click in the console, and B, again, I'm not going to violate
Yeah,
our
no worries,
policies
no worries.
on the stream.
I think we should be good to go in
Okay.
just a couple of minutes. So good news is that I'm not seeing the same error anymore.
That's good.
So maybe I can continue sharing, I guess.
Okay.
So
Yeah, that's live right
when
in.
you create the node, when you already have the node provider configured, right? And then you added the dynamic node pool to your cluster, you can actually use the UI to track the progress of the node environment. And I think this is really cool because you can see what's the input here, right? And then you can see actual tofu logs from the UI, which I think is also great. You can see all the resources that will be created in AWS. And yeah, it seems that the NAT gateway is still creating, so we're gonna probably have to wait for that. Hopefully we won't hit the quota this time. But yeah, I guess we are waiting for this to turn from pending to ready, and hopefully if that happens, then we can create actually some workloads in our vCluster standalone and then try to scale it up to see the carpenter kicking in and providing a node for our workload.
Oh, nice.
So yeah,
because
Very
we
cool.
do have some components in the cluster to run, right? Do we have like pending parts right now? Oh, it's finished, didn't it?
Yeah, it's almost finished. So the Terraform is ready. There are also some Kubernetes resources that have to be created, but I think it should work. So what happens is, so the node environment, like part of what happens right now, by default, it will also create the EBS CSI controller in my cluster and the cloud controller manager. So this way we can have even better integration with what EC2 provides, and we are ready right now. This is great.
Ooh,
this
nice.
is
work
really
on the
great.
spot. It's
So
high pressure situation here.
Well done.
So the node environment is ready. This is great. We still have just one node. We have barely any pods right here, right? So what I'm going to do, I will just create the king of the demos deployment, which is Nginx.
I think I've seen that before, yeah.
Yep.
Yeah. So we're gonna create just one for a starter. It seems that it got scheduled on my node, which is expected, right? Because I still have some capacity on my node. But right now, I'm gonna just scale it to like, sorry, yeah, that was 15. For a second, I thought I scaled it to
Oh,
okay.
We'll certainly hit the quota on this one.
Yes.
Yeah, 15 sounds a lot more reasonable for a demo.
So
although the other one, I mean, I would have been curious what happened.
Right.
That's a lot of pods.
Yeah.
That's a lot of pods.
So it will take a while, but Carpenter will notice that there are a bunch of pending pods, right? And it will try to provide the actual node that can host these pods. Right. So, and we can track the progress of that, because first the Carpenter will create the node claim, and as you can see, it already created 2. So it means that we'll get 2 nodes attached to the to my cluster. So first will be T3 small instance, right? Because what happens is that Carpenter took my manifest, seen like what I'm requesting, then check like how many pods are pending basically, and it seems that there is a bunch of them.
Mm-hmm.
Did the calculation on how much capacity is needed and what will be the best option in terms of the cost. Like what would be optimal, basically optimal instance type to host these workloads, right?
Yeah, also really shows the strength of Carpenter over like, traditional cluster autoscaler, where you have to define all these autoscaling groups in AWS for each different node type. Carpenter, you just tell it, hey, here's the 15 different node types I need. You pick whatever you need and go get it from EC2, right? So
yeah,
it's super awesome. It did like one with like 7 CPUs here, and then one with an individual CPU, I think, right?
Yeah, we can check that in the node claim. So yeah, and
really cool.
As you can see, it worked. It works. We've got 2 worker nodes attached, and you can tell that these are EC2 instances from the, let's say, from the kernel version, right? Because they have this AWS suffix. So they run on Ubuntu, and they run what was specified in the. They were provisioned with the Terraform that I specified in my node provider. So this is great. It means that all my pods are currently running, right? Yep. And this brings us to the last part of the demo. So having a lot of nodes attached to the cluster is great because you have a lot of compute. You can run multiple workloads, but then it comes with the cost of maintenance and upgrades. So as I mentioned at the beginning, we pinned the Kubernetes version when we started the vCluster standalone. And I think what we'll do right now, we'll change that version to 1.34, and we'll restart the control plane, which as a result, the control plane will get upgraded automatically. Because we haven't been able to attach the 2 other control plane replicas, there will be some downtime, so which is not optimal, but in the ideal scenario, you have more than 1 control plane node, so you can upgrade gradually. But then for the worker nodes, we actually don't need to do anything because vCluster standalone will take care of this for us. And this is what this auto upgrade setting is about. And you can set how many nodes should be upgraded at the same time. And I've just set it to 1, which means that at a given point, there will be only one worker node being upgraded. And once it's finished, then the vCluster standalone will move to the next one and we'll upgrade the next one. Okay, so back to the terminal. I think we just need to upgrade the Kubernetes version in the config and then just restart the control plane. Are you guys still here?
Cool.
Yeah, that's great. I was just not hearing anyone for a minute, and I was like, is my internet still?
You're good. I'm dialed in, thinking about what's happening. So we're waiting in anticipation.
That's great. Okay.
Yeah,
Cool.
it's hard when you're on the stream, right? You're focused on your own screen. You don't necessarily see what others are doing now. You're like, am I alone? Did the internet break down?
Am I speaking to the void and just by myself?
I've done that before, where like my internet broke down and I was in the middle of like a demo. Just like internal, right? But Zoom would just kind of quit on me, and I was like 5 minutes later, I was like, nobody said anything. Just kind of talking to myself here.
Yeah, it's especially worse if you are the one talking for a while, and then all of a sudden it's like, yeah. So as I said, I've just upgraded the K8s version, restarted the control plane. Let's see if it's up. It's not up yet. It may take a while. There would be no downtime if we would have more than one control plane nodes, but unfortunately, this didn't work on the demo. So for a while, in the UI, it will show up as it's not ready, but right now it seems to be back on ready, which is great. So we should be able to see our nodes. Yeah, so what I'm going to do, I'm going to open another terminal on this one, just to show the pods. So right now you can see that one of the kube proxies is terminating, which means that the upgrade of one of the nodes already started. Or actually, yeah, I think that's the case, and we should see the gradual upgrade to 1.34 on these nodes. Yeah, so there will be upgrade workload running on the node, and sorry, not on this node, but on the other, but it handles the entire upgrade cycle for a given node. So as you can see, the scheduling got disabled for a while, but then it comes up as the upgraded one, which is great. And now I think we are
really smoothly.
Nice. We do have one question. Is this vCluster systemd service runs as a control plane? That's yeah. Well, yes. You guys have anything to add to that?
No, that's what it is.
That's exactly it, right? Yeah.
It's a system daemon called vCluster. Yeah, running a control plane on a node. And we tried to make it 3 of these on 3 different nodes for HA, and had some struggles, I think, with these VMs to make it work on Pavel's laptop. Next time we'll probably do it on EC2 instances instead.
Right.
But we'll remember that VPC limit before we demo it. But yeah, that's exactly what it is.
Cool. Well, Pavel, thank you so much for showing us the magic of the UI, of auto nodes, and the realness of demos that we have here today.
Yep.
Lucas, thanks for joining us. Anything to add as we close out today?
I think we're like 30 seconds before we hit the 1 hour mark here.
That sounds right.
Stream. So maybe one last plug. If any of this sounds interesting, join our Slack channel. Go to slack.vcluster.com. If you have any more questions, we'll hang around for a little bit there. Scott's gonna be there. I know it's late for you, Pavel, and it's like 7 p.m. So really appreciate you staying on. Pavel may be checking in tomorrow and get a break after this, AWS debugging session here. We made the demo work in the end, though, which is really, really cool. And can't wait for all of these things that we spoiled a little bit in this session to come to fruition, and for you guys to get your hands on this as well. So definitely join us for the next couple of live streams.
Yeah, only one note from my end. So the upgrade always starts from the worker nodes, but the last stage is upgrading the actual control plane node, right? So you can see it completed as the last step.
That's what you're showing in vCluster platform and UI, right? I saw
Sorry, right
34, 34 over here. Yep, all of them are now 34. Yeah, it's really cool. Like the auto upgrade thing that's a great way to roll out upgrades to a cluster. Changing one line, applying it to the service.
For some reason you don't want to use that auto upgrades. It's opt-in.
Very cool. Well, thanks, guys. Thanks for joining us today. Thank you all for joining us on this live stream. You can find the recording on YouTube. And as Lucas mentioned, join us on our Slack channel at slack.vcluster.com. I hang out there a lot. And so come say hi and chat with us and talk to us about Standalone, about auto nodes, about other things that you're doing with vCluster. And then until our next live stream, which will be soon because it'll be showing off our next new features, we wish you all a wonderful day, evening, and enjoy your coding.
Thanks.